Hello students, in this notebook I will introduce you a PyTorch, a framework for building and training neural networks. PyTorch is a Python-based scientific computing package, a library targeted at two sets of audiences. The PyTorch library can be used as a replacement for Numpy. We can use the power of parallel computing using graphical processing units. Second, we can use PyTorch in a deep learning research for training neural network with maximum flexibility and speed. I just want to emphasize that PyTorch is very flexible, very open. There are some other alternative deep learning libraries such as TensorFlow by Google, while PyTorch is from Facebook. These two libraries are very widely used in neural network or deep learning research. First, you need to go to the following website, pytorch.org, and install the PyTorch library. There are several configurations that you can set up depending on your, let's say, machine. So Linux, Mac, Windows, which package? Conda, pip, from the source, install from the source. Which language? Python, C++, Java, we'll be using Python. And also CUDA is another main library. CUDA stands for Compute Unified Device Architecture. This one is developed by NVIDIA for general purpose programming using GPUs, graphical processing units for parallel computing. So you need to run these set of commands. Torch Vision is another package that contains a lot of useful functions when you want to work with image data. Once you install to PyTorch, we can import it using import torch. Note that PyTorch uses tensors. Tensor is actually a generalization of vectors and matrices. It's a mathematical object, and it can be easily understood as a multi-dimensional array. Like in Numpy. Numpy uses ND array, right? But the only difference between tensor and ND arrays in Numpy is that the tensors can be run on GPU, graphical processing unit, for fast computing, for accelerated computing. All right? Again, Numpy uses ND arrays to perform computation on these ND arrays, but on CPU, while PyTorch uses tensors. It's the same ND array, but we can run these tensors on GPU, okay, graphical processing unit. That's the difference. Of course, we can run these tensors within Numpy on CPU. Just, again, this is just a naming convention. Tensors are ND arrays. Just think of them as a Numpy arrays that you can run on GPU. So once we import a torch, we can create a tensor. So construct 5 by 3 matrix. We did that a lot in Numpy, right? So x, so torch.tensor, we pass these arguments and we generate this is an n-dimensional array. Okay, so 5 rows, 3 columns. We can also create a randomly initialized matrix, torch.rand. Right, so these are uninitialized array will contain some very small values just for filling up the empty array for the stability. All right, so this is another way. We can also use similar functions. This x is our tensor now. X size will give us the size. And also x, we can type x, right? What is it? Is the torch tensor object. So what we can do, x, just like in Numpy, we can check the shape. It also has a method called shape, which gives us shape of the tensor. Well, when we were learning about the scikit-learn, I told you about my favorite function called dir, right? Dir, anyway, torch, that you can use it to sneak into the Python object, what kind of methods, attributes it has. So dir torch will give us this long list of private or public attributes. These are public attributes. Yeah, these are private, let's say. So semi-private. So there are some functions that you can find similar to Numpy. ABS, maybe absolute value. Yeah. Absolute arc cosinus, add, for instance. You can just or argmax, yeah, seal, double, for instance, Bernoulli. All of them sound very familiar. So all these methods are coupled with the object. I mean, PyTorch provides this, right? So float, many others. So it's a quite rich library. Well, if you want to learn again what, for instance, let's take add MV, what this specific method does, just again, torch. Yeah, you can look it up and find the documentation. So this method performs a matrix vector product operation. Yeah. All right. So now we can just, again, treat it as a NumPy array, NumPy and the array for the beginning until you get used. So it's just torch tensor, right? The way you create. So let's make a tensor of size this 2 by 17, simple. Float tensor. So we need to define the type of the tensor, float, and we can we can take a look at this. Long tensor. There are different types of the tensor that you can define within a PyTorch library. You can check for documentations, etc. So once you create tensors, right, you can perform operations on it. So one note here is that all your data in PyTorch, your data that you will use for machine learning, image, speech data, image data, text data, okay, any other type of data will be stored or represented by tensor in PyTorch. So first, whatever data you have collected from some experiment, you need to import it and convert it to PyTorch tensor. And second step will be performing the mathematical operations on it. For instance, let's quickly take a look at some of the operations such as addition. Create a random tensor, 5 by 3. We already created the x tensor. And then addition is just like a NumPy. X plus y. We'll perform the addition between two tensors. Right? So this is our x. This one is our y. So if we add x plus 1, y gives this following tensor, new tensor. Another syntax. So we can also use torch.add to perform the same addition. Okay, and also we can define the output to be explicitly another tensor. Out will be the result. So first create a tensor, and then we add x and y and put the result to new tensor. Okay. In some cases, this is handy. This becomes handy when you define the output to be explicit. Yeah, so there is another example. We can perform addition in place. We have y. Okay, so we want to add x to y, then y that add single underscore x means add the x to the y and update the y. Perform in place addition. So any operation that mutates a tensor in place is postfix with a single underscore. For example, x dot copy underscore y will copy the content of y to x, will update the x. X dot t underscore parenthesis will perform the transpose of the matrix and then update the weight. In PyTorch, most of the methods in an object have this in-place operation. We can take a look. Dir x. X is our tensor object. So if you scroll down and find some of the methods, for example here, add underscore, a cosinus underscore. Why? There are two. So the add without underscore performs, you can add addition, but it will not perform it in place. It will not update the tensor. Well, add underscore will add and then update the weight. All of them, most of the methods have address, for example, here address underscore. Okay? Many of them. Sinus underscore. Next, indexing of tensors in PyTorch is very similar to NumPy. You can use just NumPy-like indexing. I want to get the entire row of the first column. Let me check. Oh, yeah, second column, because we're doing indexing 1. So if you do it 0, yeah, we will get all this first column. Second, okay, this one, second, yeah, third one. Shape, just like NumPy. Y shape, also very similar to NumPy. And what about this mul? So mul is, let's say, multiplication, right? In place version of tensor multiplication. You can find more operations that you can perform on tensors in the following documentation. So yeah, tensor operations, transposing, indexing. Indexing is very similar to NumPy. Slicing is also similar to NumPy. And most of the mathematical operations very similar to the naming convention used in NumPy. For example, arc cosinus, and linear algebra, inverting, or random number generations, very similar to NumPy. It is actually very easy to learn PyTorch if you are familiar with NumPy already. I will leave these 4 tasks for you. Multiply 2 tensors. Do the same, but in place. Perform in-place multiplication. Division of 2 tensors. Perform a matrix multiplication of 2 tensors of size 2 by 4 and 4 by 2 and send your answers to me. You can browse the documentations of the PyTorch if you want to find out how you can multiply tensors or divide tensors. Another feature of PyTorch I like very much is the Numpy Bridge. So converting the PyTorch tensor to NumPy and vice versa is very simple. The torch tensor and NumPy array will share their underlying memory locations, and changing one will change the other. Let's create a tensor of ones, and then x is a torch tensor. And if you want to convert this x, okay, x to NumPy, we just call it x.numpy. Yeah, so just calling the following method NumPy will convert our PyTorch tensor into NumPy. Also, we can convert these to, let's say, NumPy. A NumPy. A is a tensor object. NumPy B will give us NumPy array. NumPy is quite rich library for performing different linear algebra operations, and if you need some specific algebraic manipulation of your tensor, and you cannot find that method in PyTorch, you can convert to NumPy tensor, perform your mathematical operation using NumPy, and convert back to PyTorch. Okay, so that's one of the benefits of using this bridge between NumPy and PyTorch. In addition, most of the data that we represent numerically in Python environment or in NumPy environment will consist of NumPy array, right? So if, for instance, you load your image data within NumPy and you represent your data as a NumPy array, you can easily convert it to tensor. For instance, let's see following example. We import a NumPy as np, and we will create a NumPy array using numpy.random and .rand. This will give us 3-dimensional array with the following dimensions: 16 by 153 by 100. Now we can easily convert this NumPy to PyTorch tensor using the following function: torch dot from NumPy data. Data is our NumPy, and the B will be our PyTorch tensor. All right. B, okay, type B, PyTorch tensor, type data is NumPy. So it's very easy to going back and forth. So A is our tensor, right? Initially create tensor of ones, PyTorch tensor. Look, we can use NumPy add method by just converting this A tensor in place and adding 1 to it. The resulted A1 will be NumPy array. A1 should be 2, right? 2's, because this one we're adding. So it's very easy to connect PyTorch with the NumPy. Also, another set of tasks, simple task. Do all of these tasks and send it to me. Now, another feature of PyTorch or PyTorch tensors, as I told you, is that we can run those tensors on GPU, on graphical processing units. Right? So we can first check if I have a GPU. Looks like I don't have it because I'm using my laptop. So Torch CUDA is available, will tell you whether your machine has GPU or not. Alright, so here these are tensor created, and if we have CUDA available, we can move the tensor initially which is located on CPU to. We can try to check this on Google Colab. Let me try to open Google Colab. Okay, so let me open the Colab here. This is my Colab. Import torch, create the tensor torch, okay? And now we can check if, yeah, this is true. That means I have a GPU, while in this case I didn't have. It was false. How can we move X to GPU? We use just x.CUDA. We can see this additional entry. So device CUDA 0. Y is, let me define the same size. Tensor. We moved the two tensors to GPU, and we've performed this addition on GPU. Resulted X, Y, Z. Resulted matrix will be also on GPU. So we can convert back to CPU. We can call x.cpu, and we will obtain a tensor on which we can perform operations on a CPU. X CUDA will allow you to perform operations on using GPUs.